Hello, everyone. Welcome to the GSE UK Conference 2021. This is session 2AN. I'm going to hand you over to Wilhelm Mild, who will talk to you and tell you why you should look at Red Hat OpenShift container platform on IBM Z. Over to you, Willie.
Okay, welcome everybody. Although virtual this time again, and I hope this will change. I think you see this the same way. You know, we're seeing the need of getting together and being together face to face or talking to each other. So let's get it virtually here, but don't hesitate to ask questions. Don't hesitate to interrupt or getting to a discussion with me. I'm here to to talk to you. And if you're not getting to all the charts, no problem. You'll find them in the PDF and you can contact me. My name is Wilhelm Mild. I'm an IT architect and I'm working with customers worldwide. So really I have a worldwide role. And with the newer technologies, I'm always there because I'm an integration architect. So basically I'm looking at what can be done in a mainframe centric sense. Okay, so if the mainframe is not there, I'm not in. But if it's mainframe centric, then I'm there to see, how can we do it better? How can we do it different? What is the next step into the future with our loved platform? And therefore, with OpenShift, we have a technology now, and I want to give you now some arguments why you should look at this, and what are the challenges that I see and get as a feedback from our customers about it. And this is from a worldwide perspective, so therefore you can ask different questions as well regarding that. Now, when we're looking at today's environment, we're looking typically in these multi-speed IT environments, and the multi-speed IT environment means that we have a digital ecosystem or something that is surrounding the core enterprise, which I see in IBM Z. So basically, the transactional workload, the main data are stored on Z or are living on Z, and sometimes, since decades, they're there. And the digital ecosystem comes up with, the new functionalities, the fast speed change. And if you're looking at your mobile or your web, the new functionalities are requested on that side. That doesn't mean that the core enterprise doesn't need to change as fast as the digital ecosystem or the front end. But the point is, how do I integrate these facts? The requirements that are coming towards newer functionality in newer markets, faster to market, and therefore we see in this challenge different buzzwords, but also different challenges in terms of process changing. So, for example, life cycle. Nobody wants to shut down anymore the systems and do some maintenance on them. They want to have a life cycle that is on real time, or flexibility. We want to be flexible. We want to have flexibility in terms of granular flexibility in different areas. And there we hear the notion of, or the term microservices, to introduce microservices for flexibility. And then the question is, how do I introduce that? How do I build them? And that comes with the efficiency then, and build them in containers. So that's where my step by step comes into the game, my life cycle, the flexibility, efficiency with containers. And then I want to have that process from a development and operation perspective with together with security, so the DevSecOps and integration end-to-end. And when I say end-to-end, it is from the digital ecosystem to the core enterprise. And that's where I see the focus right now and the trend going forward. And then continuous integration, for sure. So not interruptible, or, I have a release every 2 years. That was yesterday. Today, we're looking at how can we do that in a continuous integration, continuous deployment fashion. So bringing those notions together, the trend basically is really to see what's going on in the next period of time. Now, everybody's talking about cloud native, cloud whatever. I can tell you that our analysts, or the analysts out there, they say cloud native and traditional applications will coexist for the next decade, more than the next decade. So basically, everybody that is pressing towards we have to go just cloud and do cloud, you can tell, this is not just a big switch. It is a process. It is something that we have to look at, that we have to evaluate. But the coexistence of these two, and that's why the digital ecosystem is rather faster changing their preposition than the backend. So therefore, the coexistence very important. And then we're getting to the point where we say, how can we build these hybrid services? And hybrid services in terms of, I want to have them in a very agile way built with faster speed to market, but I want my transactional and my traditional transactional data services to be orchestrated at the same time. So basically bringing that together, that's basically where we're looking at, a cloud service model with end-to-end orchestration capabilities. And with that said, it is about what can go that direction. How can we build something like that? And with OpenShift on the horizon, or basically it's available everywhere, we can fulfill a lot of this dream. So basically, when we're looking at OpenShift container platform, it runs on every public cloud. It runs on IBM Z, it runs on IBM Linux 1, and it runs on Intel, on ARM, on IBM Power. So basically, you have a technology that now can build an umbrella for managing, for automating applications, for automating the life cycle, for automating development and operations, from a full stack automation, basically, to on the left side, as I mentioned it here, to a full stack continuous integration and a continuous deployment. So therefore, it is this technology that we want to look at, because it is there. And guess what? Even if you build individual clouds on those architectures, OpenShift container platform from a single pane of glass can manage them. So that's basically why OpenShift container platform is so important these days to look at, evaluate. And as I said, it's not a black and white picture. It is a transition, it is a transformation, it is a modernization, it is whatever you call it, digitalization journey that we need to look at and see where it makes sense and how it makes best sense. And that gets you a couple of ideas in this slide, from this slide deck. Now, when we're looking at OpenShift, basically it is based on Kubernetes services. So basically, the open source Kubernetes is the base of open hybrid cloud platform with OpenShift, with Red Hat OpenShift. OpenShift itself is based on a Linux that is called Red Hat Enterprise Linux Core OS. It is based on Red Hat Enterprise Linux, but it is Core OS because it is a little different, because it is made to be deployable very quickly. It is containerized. It is made for clouds, basically, that you can have it granular. And that's why this foundation running on, on the different infrastructures as shown on the bottom of this slide, you can have that foundation now to build on top your own software, to use ISV tools and software, and to use IBM software. And therefore, the ecosystem is important, and the integration between the different softwares, the different processes are important under this umbrella of open hybrid cloud platform with OpenShift. And that's the future architecture that we see coming. And as I mentioned, it's a journey to go there. Now, with IBM, you're going there towards this environments by using the IBM Cloud Packs. Well, an IBM Cloud Packs is nothing else than a containerized software, or the containerized software packages, together with the common operational services that are packaged there together, to run on this OpenShift container platform. So with the different cloud packs, and you will see software vendors, you will see business partners, which are coming with services towards the operational services, towards their solutions, building the containers. And why containers? Because the deployment of such software is much simpler, because the management is much simpler, and because the operational part is much simpler. So that's why this is the way that we see, the future is in front of us. And it started today, or it started yesterday already. We already have a high number going that way. Now, when we're looking at the structure here, getting a little bit more into the technology, from the bottom, we're talking about containers. These containers are grouped typically in namespaces, and this namespace, this group is called pod. So from a Kubernetes notion perspective, that's the pod. Okay, so that's the smallest entity that we're working in this context with, the pod. So the pod is running on in a virtual machine or in a Linux, let's say that way, and communicates with that host kernel or with the virtual machine kernel. You do not necessarily need a hypervisor for running containers. The containers by themselves need a container runtime and a container engine. And the container runtime and engine can be multiples. There can be different ones. You probably know from Docker, you know from Podman now, because Red Hat is going to with Podman, not Docker anymore. These kind of things. But these all are, under the functional or umbrella of the Kubernetes core functions. Now, on top of these Kubernetes core functions, which are there for container orchestration, we have additional functionality, and this additional functionality is then building, or is the differentiator basically for the offerings in the market. If you're looking at Red Hat OpenShift, I just named 3 here, right? Pivotal Cloud Foundry or SUSE Rancher, they have different tool sets and components here for infrastructure, for development, for application, for image and registry management. And based on those capabilities, that's the differentiator between these offerings. All of them are basically on top of the Kubernetes core functions, and basically where the ones that fit best are the ones that you typically adopt. But the only one that can run and can manage different architectures, including Z and Power and Linux One, is Red Hat OpenShift. That's where you have to take your decision how to start and where to go with. When we're looking at more exactly on this OpenShift, what I meant with it is on the right side you see CoreOS and the container runtime, the Kubernetes container orchestration, and then we're seeing on the left side the service portal, build automation, deployment automation, application lifecycle management, service catalog. These are software components that are coming as part of the OpenShift container platform, and that's why it allows you to build, deploy, and manage your containerized workloads, and it is an environment that is really a foundation for a cloud environment. So it's not an application; it is basically a foundation for a cloud environment. And with that, we got customer feedback, and I can tell you we have a high number of customers right now that are working, that are introducing OpenShift, and we're talking here about nearly 300 that we're working with projects right now. Customer feedback for business reasons that resonated, why they are looking at OpenShift on IBM Z and Linux One. Number one was the need of being faster time to market, or high dynamic workloads. And from last year's happenings with COVID and so on, we know that dynamic workloads might be unpredictable. We might have in different areas more dynamic workloads than we had before. So therefore, OpenShift is one of these areas which can solve these kind of problems or challenges. It can solve the development challenges. While that means you can develop once and you can deploy on multiple architectures, and you can service that on the multiple architectures. So your continuous integration, continuous deployment can be from one development environment to multiple environments, and I'm showing you how that works. It enables new ways for hybrid IT projects. As I mentioned at the beginning, from the digital ecosystem to the backend, we can build those processes and enable the applications to run where they fit best or where they should run in terms of service level agreements. If you have to to run them on the most securable platform, if you need to run them on the best number crunching platform, so it might be different one. So therefore, it is really that you can enable that to deploy them where you want them based on SLAs. Digitalization, the digitalization journey, standards and openness. Everybody's looking at, we want some standards, we want open APIs, global integration. So that's where it can help, where it helps as well. And then confidential computing. Confidential computing is closer than ever for highly secure workloads, for digital asset management. And we have, companies doing that already, even in UK. And with business continuity that inherits from the stability, reliability of IBM Z. And a last argument here, what we got from customer feedback, why they embraced OpenShift on IBM Z and IBM Linux One. So from a these are the business reasons, right? When we're looking at technology reasons, we're looking at a different perspective, right? From a technology perspective, it is how this technology fits with what you or what is in the data center, or what can be done better in terms of consolidation, in terms of running effectively workload. So therefore, enterprise scale is one of the areas. You can have a private cloud in a box, and we have customers working both ways. They have a private cloud in their data center, and they have on the public cloud a failover for some applications, or an extension of that cloud for some applications. And we have the other way around as well, to extend some of those applications from public cloud into IBM Z. So therefore, there are different ways how you can build and how you can bring the value for an OpenShift on Z. Extreme consolidation, we're talking about the capability that we can run hundreds, even thousands of virtual servers in one footprint. And with tests, we have seen 2.4 million containers on one single machine. So therefore, it is really the way how you can look at it. Workload modernization or hybrid cloud with secure self-service and automation across the board. The consistency across development and operation, as I mentioned, develop once and deploy SLA-based. Co-location. Well, over 90% of the projects that we're working with right now are in a co-location with some traditional workload. And I'm showing you some traditional workload might mean ZOS. We have customers which are running 100% with Linux on Z. So they do a co-location with Linux on Z traditional workload with OpenShift. And we have customers running other operating systems, traditional operating systems like TPF or ZVSC that are doing that. So with that perspective, it is really the co-location which brings a huge advantage of integrating that dynamic workload in OpenShift with the backend or with the traditional transactional model. And then digital transformation and modernization for ZOS as well. And I'm giving you examples here how we can integrate with ZOS very effectively. Now, this is basically the picture that I mentioned. The IBM Z and Linux One is basically the one platform that can run hybrid workloads on the same platform. So we can run the multiple OpenShift environments. So you can run multi-tenancy on the same platform. You know that the LPARs are EL5+ certified, so like physical servers. You can run multiple clusters on the same platform. You can run them side by side with ZOS, side by side with Linux, or side by side with ZVSC, ZTPF. So basically, there is no exception. And what I want to say is this is basically the isolation and at the same time the hybrid value running those OpenShift environments on the same platform with the highest security, isolation, and very important, with the hypervisors that we have, be it ZVM or be it KVM. It is the granular sharing that we have available and the shift of the capacity from one virtual machine to another one, whoever needs it, that is unique on Z. Now, For infrastructure management, we have this new IBM Cloud Infrastructure Center that is available now, and it gives you the capability for software-defined everything, software-defined data center. It can be used from OpenShift, it can be used from VMware, it can be just used from Ansible from an automation perspective, and it builds the capability to automate and manage your compute nodes, virtualized in ZVM, KVM, your storage with fiber channel, so basically SCSI and DCKD, and the network. So that's basically, you know, for software-defined data centers or software-defined everything on the future, it is one of the central pieces for infrastructure as a service. When we're looking at OpenShift itself, we have a new capability with OpenShift version 4.8, which came out in July. We are now on OpenShift 4.9, and you have the capability to have a minimum installation scenario out of 3 virtual machines in an hypervisor that can be ZVM or RHEL KVM in a single LPAR. So the 3-node cluster basically unifies the control plane and compute node functionality in a single node. That was not possible before. Before, we had to have the 3 control planes separated from the compute nodes, and the compute nodes could be 2 or more. And here now we have the capability to just run 3 nodes, and every node is hybrid. So basically you can try out and test and, you know, do development in a such environment. That's the minimum installation scenario. It is there for, you know, starting up quickly and using it effectively in one LPAR. If you want to build a production environment, basically OpenShift based on Kubernetes comes in a high availability setup. The high availability setup means you have to have 3 components for high availability, therefore 3 control planes, and then compute nodes at least 2 for high availability. And for the high availability as an infrastructure, we propose 3 LPARs, which can run in 1 or multiple physical machines. So therefore, it is the capability to build that environment and run it side by side again with your traditional workload. Now, when it comes to storage, and that's one of the areas that I got the most questions. Well, do I need a new storage infrastructure? What do I need for it? Think of that these nodes here, control planes, compute nodes, and infrastructure nodes. The infrastructure nodes are special nodes for, you know, monitoring, for example, of the cluster, so that you externalize those services from the compute node and reserve the compute node for the real work. So basically, these nodes are all virtual machines. The virtual machines need to start to IPL from a local attached volume, and that's why I called it hypervisor storage. If you look it in the literature, you will not find that notion. But just to understand, the hypervisor storage is basically building or is giving you the storage needed for the hypervisor itself and the virtual machines. Now, the applications which are running in these compute nodes, your containerized applications, they need container storage. And basically, again, container storage is something I use that you understand. It's a different storage. You can use your local disks, but they will not be shared in that case. So if you have applications running on 3 LPARs and you want to share the data, you need a storage that is a shared file system, and that shared file system needs to be defined as an either network attached storage or a solution that you can attach these nodes to, that your application can share and access the same data at the same time. And that's why for this storage, you have 2 options these days. One option is IBM Spectrum Scale with a container native storage access enhancement. So basically, the CNSAs, as shown here on the left side, is the component that is installed or is set up in an OpenShift cluster. It's using the container storage interface CSI, and so with the CSI driver, it attaches to the nodes, to the compute nodes. You see that it is not attaching to control planes. The control planes just need your local storage, and the Spectrum Scale container native storage access now accesses through a cross-cluster mount to an existing or a Spectrum Scale storage cluster that can be an enterprise storage cluster, and a Spectrum Scale ESS storage, and with that you can share. All the applications can access the same data through Spectrum or on the Spectrum Scale cluster. The advantage of having that is also that you can build basically a hybrid storage cloud for your enterprise, because you can have your x86, your power system, your ZOS, your Linux accessing these data. And that's one of the areas where we see customers right now from different perspectives. They're introducing IBM Spectrum Scale cluster. And one of the areas is that they build a data pool. You can call it data lake, you can call it data ocean. We have, you know, customers, they say, you are so big in data, we're building a data ocean. And you can store data from OpenShift, you can store data from your traditional applications on Linux, or even ZOS with an effective NFS interface to Spectrum Scale, and share those data across different platforms. So that's how OpenShift can use the same Spectrum Scale cluster as other systems, and vice versa. For OpenShift, you can introduce it. Another capability that you have is Red Hat OpenShift Data Foundation. This was called previously OpenShift Container Storage. And the OpenShift Data Foundation, as the new name, is a shared persistent container storage. So basically, you can have your ECKD or SCSI disks that you have today, your DSAK if you want, attached to Z, and then install the software for OpenShift Data Foundation. And this software makes it now possible that you can share one disk across your application nodes, again, using the container storage interface. And therefore, this basically is the capability that you have another type of shared storage for your OpenShift cluster. The differentiation to Spectrum Scale, and here, one or a major one, is the storage here is attached directly. You see that through the ECKD disks. That means you cannot share this ECKD disk now with another cluster, which you can with Spectrum Scale, because there you have a storage cluster which is attached to the OpenShift cluster. Okay, you have some more details about that in the PDF if you download it. I'm just showing you here, you know, arguments and how your storage can be used. Now, another point which is very important here is development consistency and productivity. So OpenShift enables the developers to have the capability of developing very effectively, but also building this the life cycle and CI/CD, continuous integration, continuous deployment pipelines. OpenShift comes with this functionality in it, and guess what? It's not a feature that is a paid feature, it is included. And when I say included for application services, you have the capability to use service mesh. And this name, you know, it's not necessarily saying what it can. Service mesh is the capability to have a secure communication between your microservices inside your OpenShift cluster. Without service mesh, you would need to do that on a 4-level setup. With service mesh, it is very easy without touching your applications. Serverless is the capability to build applications which are just, you know, using capacity if it's needed, if they are started, and they you know, they stop themselves if they're not needed anymore. So that's why it's serverless. And then you have runtimes and middleware for applications to build them easier. Next to that is the development tools and the automated builds that you can do with the tools that are included or coming with the OpenShift container platform. And again, they are included also from a subscription perspective, from a pricing perspective. When you want to build those container applications, you have the capability with OpenShift itself to switch between an administration dashboard and the developer dashboard. Now here is shown the developer dashboard, the developer view, and you can build your application from source code, from an GitHub, for example, from a source repository. You can build your application from a container, existing container image, from the IBM container image repository, and I'm giving you the link there. Or you can build them from a so-called Docker file. The Docker file is basically a text file which tells what is needed for that container, what is included in that container, what needs to be installed in that container. And last but not least, from the OpenShift catalog, where we have a high number of pieces already included, and we're talking here of hundreds of components already for Z and Linux One. Now, if you want to develop based on application, based on tools that you know about, you typically have your ZOS environment and you have an OpenShift environment next to it, as mentioned before. You can run them side by side, and now you want to develop applications, so you can use the command line interface tool OpenShift Do, called Odo. So OpenShift Do is a command line tool that it is used to build, deploy applications in OpenShift. The second capability you have is you can use Microsoft Visual Studio Code. Visual Studio can use Odo as a plugin, and again, through the existing tool, if that's a tool that you're using in your enterprise, you can use Visual Studio Code, VS Code and Odo as plugin to develop those applications for OpenShift. And the application from OpenShift can then access your ZOS. We're coming in a minute to that. Number 3 is Code-Ready Workspaces. Now, Code-Ready Workspaces is another plugin in OpenShift that gives you a graphical user interface and integrated development environment in a browser. You do not need to install anything in the browser, and you can develop these applications for in OpenShift for OpenShift. Now, in addition to this, the capability to use OpenShift as a development environment, even for pure ZOS, is given, because you can have now on your Intel platform where you do the development an Code-Ready Workspaces plugin and Vazi as an editor, the open source editor that was developed by the Open Mainframe project. And with Vazi, either in a Red Hat OpenShift Code-Ready Workspaces or even in Visual Studio Code, you can develop and deploy directly into ZOS with the capabilities that you all know from a graphical development environment, from an integrated development environment. And therefore, it is the nice capability here to either use Red Hat OpenShift as the development tool set, or Visual Studio Code in conjunction with it, and build those applications. And last but not least, Cloud Broker is a plugin for OpenShift that you cannot develop but manage and deploy your subsystem in ZOS. So basically, you can deploy here your DB2, your CICS, an IMS, an MQ environment with Cloud Broker. Again, this was an overview about cloud native development tools capabilities, and all these capabilities are outlined in more detail in the PDF that is attached from my presentation. Now, when you develop this application and you develop them on your laptop, for example, you want to deploy them on the different platforms. And that's, again, possible if you're using OpenShift on x86, developing that application with the tool called Argo CD. You have a full control of deploying that application on a public cloud, deployed in IBM Z and Linux One or IBM Power. Now, guess what? Similar to that with OpenShift pipelines, and that's based on the open source project Tecton, you can build an automation to even deploy into ZOS. So the automation can go from a deployment to different clouds or different platforms to a development and deployment into ZOS with code-ready workspaces here as mentioned as well. So basically, from a development to a deployment, you can automate through OpenShift pipelines. And just giving you, an overview here, the OpenShift pipelines have the capability to interact with Ansible that is available on our Z platform everywhere. So therefore, the capability of interacting with the different tools to build the applications, to automate the deployment, to scale them, and therefore a very effective way of using OpenShift on IBM Z. Here you have the DevOps. And with DevOps, you need the CI/CD pipeline inside the lifecycle management. And OpenShift pipelines, Tecton, give you the capability to do that, to do your continuous integration and deployment from OpenShift, including ZOS. So therefore, an end-to-end capability that is available. Red Hat OpenShift gives you the capability to have operational experience as well. So you have logging and monitoring included in OpenShift. And it gives you the tools like, Elasticsearch and Prometheus for alerting, Grafana for collecting and showing that, Elasticsearch for analytics. So therefore, you have the most important tools available, but you can also externalize logging information, basically, if you have a CM or you have an external logging tool that you want to stream those logging information into an external tool that's capable, that's possible as well. So therefore, another advantage of OpenShift and using it on Z, you have that capability as well. Now, Z versus x86, it is always, why should I use it on Z? Does it make any difference? Well, we have a multi-tier application capability with OpenShift, and we have seen that it makes a lot of sense to bring that environment on IBM Z, because we see much higher throughput on a per core level and a lower cost when we run that, and therefore we see a significant better performance using OpenShift on Z. The ideal use cases that you want to consider or you want to look at is basically the number one use case is data gravity. The collocation implementation of containerized applications with a traditional, and no matter what the traditional means, and we're seeing a couple of examples in a minute. Then application development consistency. Again, to develop once and deploy based on the options that you define. So option could be to run fastest, to be closest to the data, to be on a very secure environment, and therefore it depends on the conditions that you define. You can build that application consistency in the process to do that. Consolidation and TCO reduction, a 3-dimension scalability, so we can scale horizontally as x86 does, but we can scale vertical, and that's basically where we see the biggest advantage that our customers are telling us. Scaling vertically means I have my applications running, and if I need more capacity, I just enable that capacity, and I can disable it if I do not need it anymore. But enabling capacity on demand without the need of defining new servers, bringing them into the system, including them into the security zones and all that, that's a huge advantage. Another use case that is gaining more and more traction is blockchain and digital asset management. So basically, with confidential computing in mind, building that blockchain, and right now we have the couple customers doing that already with blockchain services managed by OpenShift on Z. So IBM blockchain platform can be managed by OpenShift. And last but not least, business continuity. So basically the high predictability and resiliency is much better on Z than we have it on distributed environments, distributed servers. And the latency between those servers, the more complex the network is, the more difficult it is to predict network congestion. Therefore, having them in LPARs, the communication between the LPARs is much more predictable, and we have the capability to use internal network communication or shared network cards on our Z platform. So therefore, these are the ideal use cases. And if you want to listen or want to hear more about them, there's a webcast and recorded webcast that is where the link is on the bottom with the best use cases for OpenShift container platform. As an overview here, more technical now, we're getting to see that OpenShift needs to run, first of all, in a virtualized environment. So we need an hypervisor. And here we can use ZVM, IBM's hypervisor, or we can use Red Hat KVM. And Red Hat KVM is part of the OpenShift delivery if you want. So if you order OpenShift, you also get KVM in the context of OpenShift so that you can run OpenShift virtualized in Red Hat KVM. If you have ZVM already, I would suggest to stay with that and use ZVM for OpenShift as well. And you know the tools and you know how to operate it. On the left side, you see Linux on Z as the traditional environment where you can integrate with data and services. And on the right side, ZOS as the traditional environment. And OpenShift builds that umbrella or builds that scalable environment that is bridging then into the traditional environments for data or services. If you're looking at these now one by one, with Linux on Z, we have the bidirectional capability of the integration for transactional systems, automation, web integration or mobile integration. And we have the capability to integrate with the data. We have many customers that have an Oracle, a consolidated Oracle environment on Linux on Z. Well, with OpenShift now, you can have that scalable environment in applications and connect to that Oracle database or those databases, or to a DB2 data warehouse or any analytics there, or build the analytics pool for further analysis that can be done through OpenShift or through other tools, which are traditional then. So therefore, there are different capabilities that you can do with Linux on Z as the traditional environment. When we're looking at the ZOS side, we have many customers, as I mentioned, over 90% is a co-location with ZOS right now. So co-location with ZOS means a scalable workload or a containerized workload that can run on OpenShift side by side with ZOS and interact then with DB2 ZOS, interact with ZOS services, with REST services through ZOS Connect. And as you know, ZOS Connect can do bidirectional communication. So bidirectional means you can have a ZOS service that is accessing or calling a containerized application in OpenShift, and vice versa, that OpenShift containerized applications are communicating with ZOS services. You can also have OpenShift containerized workloads interacting with the container extension in ZOS. So ZCX as the container extension workload, interact with that, also bidirectional. ZCX can initiate interaction with OpenShift and vice versa. And last but not least, ZOS Cloud Broker. With ZOS Cloud Broker, you can manage your subsystem, your ZOS subsystems, deploy these subsystems, and therefore have the automation in place. And with that automation in place, you can unify the different processes that you want to have, be it the deployment, be it from a development perspective, be it from a process perspective. And with Ansible automation on ZOS and the OpenShift capability, you can automate much more from an OpenShift perspective. So the flexibility here is very big. Therefore, it depends on how you look, or what are the use cases that you think makes a lot more sense for your environment. And feel free to contact me. You have my contact on in this deck. Contact me to discuss if you have any idea, if you want to bring some applications, some processes together with an OpenShift environment, and let's talk about it, because it makes a lot of sense to think about it. We have a customer that is doing batch workload management from an OpenShift environment. So they're running their batch workload in an OpenShift environment with z/OS data access. That's also very interesting environment. I just see here a question now. Can all the software to build an OpenShift environment be downloaded from Red Hat? Is the software free unless okay? I will postpone this question a couple charts, because I show you where you can download software for OpenShift, and show you how you can build the applications with pre-built container images in OpenShift. Okay. So with that said, I'm just showing you now adoption patterns. So we talked before about use cases. Adoption patterns means customers are doing it today. They are doing today their collocation. So collocate containerized workloads with z/OS, with benefit from the lower response time and meet the enterprise SLA and availability. And you see a couple of industries that are underneath each of those adoption patterns. Modernization, adopt cloud native on IBM Z. I get code from customers that they say, every project that we do has to do something with cloud. And I keep saying, if you enable services that are enabled for automation, self-service, and eventually chargeback, you have built a cloud service. No matter where and how you run it, you can build around that an automation that is cloud enablement. That's cloud enablement. You can also have services which are connected to a cloud that is basically delivering some information, and therefore from a modernization perspective there are different capabilities doing that. So modernization, another adoption pattern that we see, taking advantage of the Z strengths and leveraging the continuous integration capabilities. Platform specific advantages, again, latency, throughput, resource sharing, very important, resource sharing and shifting from one node to another, or the vertical scalability, multi-tenancy and security as high advantages. And we see right now, very interesting, the second wave of investment. We see customers that started small and now they see the big advantage of OpenShift on Z, and they're investing now heavily, going forward in huge and big projects with OpenShift on Z. z/OS integration. You can integrate on a data and services level, and you will see more coming into this area, because that's the area where we're focusing heavily on, how we can build and integrate z/OS traditional workloads more into hybrid cloud and make that as a part of the hybrid cloud strategy, not strategy, but solution. And therefore stay tuned, that's a lot of that will come there as well. Similar to data and AI on Z. AI on Z is something that started, and we see now more and more that customers are looking into how can I, leverage the data where they are. How can I make that, as of an advantage as I can? So basically, to use the capability of analytics, and therefore OpenShift helps there with the parallelism to the data and even building those data pools. And then last but not least, blockchain and IBM blockchain platform managed with OpenShift. So you see here, these adoption patterns means customers are doing it. We're not, that's not the use case you might or you should, or that's not a dream. It is what is done already or what is implemented already at customers. Now, two examples here. One, reducing operational disks, just converting from a VMware environment into OpenShift on Z. And I mean, and if you're looking at bringing from an Intel perspective that on Z next to the data or the services that are on ZOS, with in-memory network communication through hypersockets or even through shared cards, we had the latency got down. So they have a big advantage here with over 7x lower latency due to colocation. And even another example that I have here is basically that customers started to develop applications. Well, we need to go cloud. We're starting developing in the cloud. While developing in the cloud is one, but if you're running productive in the cloud with having backend data, you might be surprised how many hops are in between before you get to your data, how many routers and switches you need to overcome to get to a performance. And therefore, by moving from a public cloud to an on-premise environment, on-premise cloud in OpenShift Liberty application, these customers got from 1,500 queries per minute to 650,000 queries per minute. So in average, it was a 43 times improvement, which they said, okay, that's the way to go. So let's heavily invest now to bring that environment and make that environment happen. So with that said, it is basically the way we should look at. It is the way that customers are going, and it depends on the use case, how effective and how big the differentiation is, what you had and what you will have with OpenShift on Z. Now, the outlook for OpenShift on Z means we want to have a hybrid multi-cloud operational model for everything that runs everywhere, if you want, controlled by OpenShift. So OpenShift basically being the one that can manage those workloads, those containerized workloads. Are we there 100%? Not yet. There are a couple of items that are still marked here with a star that are in work. We're working on them. But what we have today already is we have an advanced cluster management. So even if you build different clouds, different OpenShift environments in the public cloud, on your x86, on your Linux on Z, you can manage them from a single pane of glass. So basically, with advanced cluster management, you can manage that already today. And that's where I think the advantages of not just having OpenShift, but also building those environments. And with IBM Z and Linux One, you can have the core of your secure hybrid cloud, and surrounded by different systems, you can use IBM Z there from the startup to build that environment. Therefore, unparalleled trust and security, and from a single point of security for your data and services on Z, you can extend that, and with OpenShift, you can still keep the highest security on Z and have OpenShift as the highest scalable environment for your containerized workloads. And you can support whatever you need, whatever you want, from a mobility to different environments. Now, do you need access to an OpenShift environment? And you think, well, I don't know, to install it, it might be, I need time. If you want to have access today, now, in the next 5 minutes, you go to the right side here, try OpenShift Container Platform on our Linux One Community Cloud. You get a ready-to-run OpenShift environment, and you can try out your software or your container or whatever you want. If you just want the Linux on Z, that's on the left side. So fast start guide with that. But a ready-to-run OpenShift environment can be used here from the OpenShift Linux One Community Cloud. If you want to download OpenShift, the latest version came out in October. So we are on all platforms at the same level, and that's the beauty of that as well. The same day, same hour, all the platforms will release the same, have the same version, the same release of OpenShift. If you want to create your own cluster, you can download that through the Red Hat cloud and install it and have a 60-day evaluation. Now, the question came, where do I get, the container workloads can I download from OpenShift catalogs? You can download, first of all, now very new, from a trusted container registry from IBM. IBM Z and Linux One trusted container registry went live. It was in beta for a couple of months. It went live last week. So therefore, it's a new channel for open source container images. And you see them here in an alphabetic order. So there are lots of container images that you can use to build your OpenShift solution, or use those components just as containers inside OpenShift. You can use them as well as native containers without OpenShift, but it's up to you where and how you want to use them. But that's number one. Then you can use from Docker Hub with the filter of IBM Z, as I mentioned here on the left side, where you see Docker containers. This is something that some customers are not necessarily happy with, because they're uncertain what is on Docker Hub. In terms of some customers are not allowed to access Docker Hub because it's a public repository. That's why the IBM repository is a trusted repository now. The next available capability is with the open source software that we converted or we migrated to Z, and they have on this column here with Dockerfile image, you can have either the way how to build that container or the container image by itself. So that's another way where you get it. And last but not least, from the Red Hat catalog container image. I did not take this image from today, but there were almost 600 already available there. So every day it is growing. So therefore, from the Red Hat catalog, you will have container images that are available, and with the checkmark of S390, as shown here on the left side, you can get those which are for IBM Z and Linux One. For partners, if partners are in the call right now or they are listening to this presentation, you have capability to contact us and be part of the initiative to help you in this arena, that you're making available your solution as partners for our all customers, that we see those solutions coming along also for OpenShift. So the Linux One Partner Network. And with that, I have a couple of useful links here that you can use. One that I want to point out is the reference architecture for OpenShift on IBM Z and Linux One. That's a document which has a lot of explanations. What are the options for networking, for storage, and so on, for setting up that environment. That is available for public. So basically, it is available for customers, for partners, for IBMers, no problem. Therefore, use it and give me feedback if there is something that we should add. And with that, basically, I just want to point out we have a new community that is a technology interchange community, the community for Linux on Z and Linux One. We're talking about all topics about containers, about Linux on the mainframe, about Linux One. So therefore, register to it so you can be part of those discussions. It's an interchange community.
William, we've got a question in the chat.
Yes.
Is IBM support of Red Hat OCP a separate chargeable service? Can customers raise tickets in the event of an issue with the underlying infrastructure?
Sure. Absolutely. OpenShift is a supported environment. So therefore, you can raise tickets for OpenShift and tickets for the underlying infrastructure that OpenShift is running on.
Okay, thank you, Wilhelm. Any other questions?
I saw that, you know, one question was about the presentations, and I will make the presentation available. So basically you can download those presentations no matter how you make them available.
Yeah, you can upload those to the GSE site yourself, unless you want me to do it.
I can do that if I have the link. I'm looking for it, and then
if you log into the same place where you registered, and you should be, as a speaker, you can upload the slides.
Okay, I will do that. I did not see that. Sorry for that. I did not.
If you have any trouble with that, if you have any trouble with that, just send them to me and I can do it for you.
Thank you. Yeah, sure. Wonderful. Thanks a lot for your attention.
Yeah. Okay. Thank you for attending. The session was 2AN. I'll put up. I'll share the QR code now, and if I can figure out where I share it from. Share screen. Here we go. Do you want to stop sharing there, Wilhelm? And then
I did.
All right. Okay.
You should be able to share.
Share. No, it's not letting me do this. Okay, I can't put that up there, but
you cannot share?
No, it's not allowing me to share the screen I had. So
okay, that's interesting.
No, I can't share it. It's
I stopped. What can I do else? I stopped sharing.
Yeah. Okay, not to worry.
Do I need to make? Well, oh wait, but you are.
You should have had a QR code sent to you that you could put at the end of the presentation to display the details. But for
some reason I didn't get that. I didn't see that eventually. Okay. Anyway.
Okay. Thank you very much, everyone.
2 a.m.
We'll try and sort something out.
Thank you. Thanks a lot.
Bye.
Bye.
Wilhelm, perhaps I'll send you the QR code and you can add it to the PDF, and then when they download it, they've got the details then.
Super.
Okay.
Please do that. Yes.
Okay. Bye.
Bye.